Okay, dear students, let's see what is there. In this question, a company delivers packages to customers using a small unmanned aircraft. Rotating horizontal blades exert a force on the surrounding air. The air above the aircraft is stationary. The air propelled vertically downwards with the speed v. The aircraft hovers motionless. So the aircraft manages to hover motionless above the ground. It means that neither the aircraft is going in the upward direction nor it is going in the downward direction. It means all of the forces are just balanced there. So the net force there should be equal to zero. A package is suspended from the aircraft on the string. The mass of the aircraft is 0.95 and the combined mass of the package and the string is 0.45 kgs. The mass of the air pushed downwards in 1 second is given as 1.7 kgs. State the value of the resultant force on the aircraft when hovering. So clearly the answer for this is zero, isn't it? As I've already told you, that because it is clearly written here that aircraft hovers motionless above the ground, so it is not falling under the influence of weight. So why is it not falling? So weight is the downward force which is acting, and there is an upward force which is coming due to the reaction part of the action which is created by the blades. So that upward force is cancelling the downward force, and that is why the net force is zero. So zero will be our answer. Let's see what is written in the mark scheme. And clearly you can see the answer is zero. Let's go for the next question now. Outlined by reference to the Newton's third law, how the upward lift force on the aircraft is achieved. So that's pretty clear, like why the from where the Newton's third law is coming into picture. So we can just explain it like the blades are pushing the air downwards, and there is a force on the air by the blades. So as a reaction part of that force, there is a force on the blades by the air. That becomes the reaction part, and that is why the blades here, they are experiencing an upward force overall. So overall there is an upward force on the aircraft which is balancing the weight. So in the theoretical questions, you see, you can write whatever in your terminologies, like the way that you want to write. But it is very important for us to concentrate on how they have written the answers, so that when we write the answer, that should go somewhat similar to the terminologies which are being used by IB. So they have given the answer only in two statements. The blades exert a downward force on aircraft. Air exerts an equal and opposite force on the blades. So it's clearly Newton's third law. They are not at all explaining that further. So you just write these two statements and you're good to go. Determine V. State your answer to the appropriate number of significant figures. So we have to find the velocity. So determine V. Determine word means that you have to use the mathematics. Okay. These are some keywords. Like if they say explain, if they say describe, so you need not to go into mathematics. So when they say like this thing, determine or something, then you have to go for the mathematics. Okay, so one thing is pretty clear, that we would be using the formula for the reaction force in this question. So if you have if you are connected with me in my private classes, or if you have watched the video lectures that I have uploaded on the YouTube channel, you might know that there is a force which is called reaction force. And the formula for this is given as F is equal to V into dm by dt. So V is the speed at which the air is thrown in downward direction, and dm by dt is the rate of mass flow, like how much mass of the wind or the air is thrown in 1 second, which is clearly mentioned as 1.7 kg per second. So as a very big hint, I would say whenever this kind of value is given, or this unit is given, 1.7 kg per second, it clearly means that we have to apply the formula, the reaction force. Sometime or the other we would be using that. So it was pretty clear that we would be using this formula. So the students, those who don't know it, there are two type of forces: m into dv by dt plus v into dm by dt. This part is known as reaction force, this part is known as inertial force. So usually these things are not given properly in the books, and you might not be aware of this thing. So I have uploaded the lectures there on YouTube. So if you have not yet watched them, you please watch those videos. Okay. So F is equal to V into dm by dt. We just find this value. It is coming out to be V into 1.7. V is the speed, and this is 1.7 kg per second. So this is the upward force on the aircraft, on the blades total. So it is the total upward force on the aircraft, which becomes 1.7 into V. Now, because it is just hovering motionless, I can just say that it is actually equal to the downward force, which is the weight. Now, what is the total weight here? So the total weight is the total mass, which is 0.95, the mass of the drone, and 0.45, the mass of the package, or the bomb that the drone is carrying, you can say. So 0.95 and 0.45 into the gravity, which is 9.81. These days drones are used not to send the packages, but they are used to send the bombs through the border. So 0.95 plus 0.45 into 9.81. So this is the equation, and we can just find the velocity with which the wind is blowing down. So I'm not finding I'm not doing the calculation here. I will just show you how they have done. And absolutely correct. They have done in the absolute same manner. 1.7 into V is the upward force, that is the reaction. 0.95 plus 0.45 is the downward mass, multiplied by 9.8 will give you the weight downwards. We are balancing these two things, and so the velocity becomes 8.1 meter per second. So 8.1 meter per second is the velocity that the wind is moving downwards with. Okay, now, so the next question is, the package and the strings are now released and they fall to the ground. The lift force on the aircraft remains unchanged. So the upward force is remaining unchanged. Calculate the initial acceleration. Okay, so the total lift force, the upward force, it will be given by 1.7 into 8.1, isn't it? Because it doesn't change. So you can say that the velocity with which the wind is going down and the rate of mass flow rate, even that is constant. So overall, the reaction force on the aircraft remains the same. This. And so what will be the acceleration? Okay. So there is the weight of the aircraft. Now this 0.45 is no longer there, but this weight is still there to be balanced. So the weight of the drone is still to be balanced. So what is the F net? So the net force will be the upward force minus the weight, which is 0.95 into 9.81. So we can calculate this, which is the net force. Or you can just imagine, like a kind of like common sense, because there are two masses there and the upward force is balancing these two forces. So one string is cut. It means now the weight of the package and the string is the only upward force, like that is the only net upward force with which is acting on the drone now, because this weight is still intact. So this is the only upward force which is remaining. So you can even imagine that. So this can be written as 0.45 into 9.81 if you just want to cut short your calculation, but need not to worry because you are having your calculator. So if you understand this part, you can use this formula. If you understand this part, you can use this formula. Both of them are correct. These forces, they will be equated with m into a. Now what is the mass of the drone? Only 0.95 is the mass which is still there, and it chooses to go with an acceleration of a now, as because of the force which is acting on it. So we just equate this with this. So let me do it here, like 0.45 into 9.81, and you can find the acceleration a. That's it. So again, I'm not doing the calculations here. I will just show you what they have done. 0.95a. Let us see. Absolutely correct. 0.95 into a is equal to 0.45 into 9.81. Exactly the same equation that I had written. Like you see, 0.45 multiplied by 9.8 and 0.95 goes to the denominator. So it's exactly the same equation that they have created. So your answer comes out to be 4.6 meter per second square. This is the acceleration with which the drone will start moving in the upward direction now as soon as you cut the string. Okay, so this is it. And okay, so there you go. The question is over. This is how we do this question. Okay, dear students, thanks for watching this video. Keep watching, keep learning, and get 7 on 7. All the best.